Good morning, students. After the introduction of electrochemistry, now we are going to discuss electrolyte. So that means types of cells. Two types of cells is there. One is electrolytic cell, another one is electrochemical cell. Before that, we need to know the what is conductance. Conductance. Conductance means which of the substance which of the substance allowed to pass electrical current electrical current, which of the substance allowed to pass electrical current, that substance, that means electrical current means that is a flow of electrons are flow from the substance. So this substance as like solid one is there and liquid one is there. So which of these substances does not allow to pass the current, those substances are called as insulators. Insulator. So like we take the example as rubber and wood, these are act as insulators. So from this substance the electrons does not flow. And conductors, we take the best example, insulator also you take the example glass, wood material, insulators, wood materials, rubber, we take these are insulators. And conductors, so depends upon conditions, these are sometimes allow, sometimes does not allow, so those are called as semiconductors. Conductors are metals, and insulators are act as non-metals. Most of the non-metals are like insulators. And semiconductors like silicon, germanium, so these are act as semiconductors. Because of these are these are called as metalloids. So and in electrochemistry point of view, some of the substance allowed to pass the current, those are called as conductors. Solid conductors, like we take electrodes. So electrodes, so these electrodes are solid materials, these are made with metals, like copper metal, zinc metal, iron metal, like that. These electrodes are made with metal, and these are allowed to pass the current. Electrons are flow from these metals one position to another position. These electrodes are dipped in electrolyte. And what is electrolyte? Electrolyte, this is a one solution. As liquid one is allowed to pass the current, that means the flow of electrons that take place from the one position to another position in this liquid. This is called as electrolyte. So these electrolytes are two types: strong electrolytes and weak electrolytes. Strong electrolytes, weak electrolytes. Strong electrolytes, we take NaCl as example. NaCl, HCl, these are act as strong electrolytes. And weak electrolytes, that means they are also allowed to pass the current. Flow of electrons is take place, but that is a very slow compared with this one. And weak electrolyte, like we take the acetic acid, CaCOOH, weak electrolyte. Electrolytes. So electrodes are solid materials. These are made with made with metals like iron, copper, zinc, like these metals, etc. So cells are classified into two types. Cells are classified into two types. One is electrolytic cell, another one is electrochemical cell. Electrolytic cell and electrochemical cells both contain difference. In this electrolytic cell, it is a phenomena is take place. Electrical energy converted to the chemical energy. Electrical energy converted to the chemical energy. That means by the passage of electrical energy, the chemical reactions are take place in non-spontaneous chemical reactions. Okay. So by the passage of electrical energy, chemical reactions are take place. Those are belongs to the non-spontaneous chemical reactions. Okay. So that is belongs to the electrolytic cell. And after that, next one is another one is electrochemical cells. This is electrolytic cell, this is a electrochemical cells. So also called as this is a galvanic cell or voltaic cell. In this, the process is going on as a chemical energy converted to electrical energy in spontaneous chemical reactions. So in spontaneous chemical reactions, the chemical reactions are take place. So during this chemical reaction, the energy is converted, chemical energy is converted to electrical energy. We find out the how much amount of electrical energy is converted by using of voltmeter, ammeter, like that. Okay. So this is two types, electrolytic cell and electrochemical cells. E to C. What is mean of E to C? Electrical energy to chemical energy. Okay, by applying of electrical energy, chemical reactions are take place. That is E to C for electrolytic cell. And electrochemical cell. Electrochemical cell or galvanic cell or voltaic cell. In this C to E. C to means C is a chemical energy converted to electrical energy. So this is difference between the electrolytic cell and electrochemical cell. Okay, now we are going to discuss electrolytic cell. Okay, electrolytic cell. In this electrolytic cell, so this is made with glass material or insulated. That means insulator. It is made with glass material or insulator. So we call that this is cell, and cell contain electrolyte. Electrolyte. This is a liquid. Is aqueous solution. This solution is electrolyte. These are called as electrodes. These electrodes are made with metals. Okay, and these both are connected to the external battery. That means they both are connected to the battery or electricity. Okay, so this is a structure of electrolytic cell. By applying of electrical energy to this, so this is a positive one, this is a negative one of this this battery. This positive one is we called as positive plus. This is a minus. So by the presence of this positive charge of the battery, this electrode also generated positive charge. So we call as this is anode, and this is anode, and this is cathode. Okay, cathode. For example, we take the electrodes are made with copper material. So these both electrodes are made with copper material. Okay. The cell reaction take place by using of its electrode and its electrodes and its aqueous solution. Okay, its salt solution. Aqueous solution or salt solution. Electrodes with its salt solution we take. Salt solution we take the in this solution electrolyte is electrolyte CuSO4. This electrolytic cell contain two electrodes. These are made with copper material, and electrolyte is its salt solution. So this is a CuSO4 copper sulfate, and this is copper. This is also copper. So by applying of external electrical energy to this, so the reaction is take place. The cell reaction is, that means the reactions are take place in this. So by applying of electrical energy, the chemical reactions are take place in this. How? And at anode, what happen in this? At cathode, what happen in this? For example, we take in this copper sulfate solution, and two copper electrodes are present in this. And what is the reaction phenomena is take place in this? So at anode, oxidation is take place. Oxidation. At anode, oxidation is take place. At cathode, reduction is take place. In this, reduction is take place. In this, oxidation. At anodic position, oxidation is take place. At cathodic position, reduction is take place. How it is oxidation is take place? How it is reduction is take place? So in this copper ions are going to form as Cu plus 2 state. That means by the liberation of electrons, copper plus 2 state is appeared. The electrons are flow from this way and copper plus 2 state. So that means electrons are flow from anode to cathode. Electrons because of positive charge. Okay, so that is the reason we initiated positive for this anode. So this copper electrode, the copper ions are liberated as in the formation of copper plus 2. Copper ion we called copper ion because of copper plus 2 state. Copper liberated in the formation of copper plus 2. The electrons are flow from in this, by liberation of electron in this, electron will flow from the anode to cathode. So electrons are present in this. So these copper ions are going to occupy in the these copper ions are going to occupy on the surface of the cathodic electrode. Cathodic electrode position surface area is occupied by the Cu plus 2 ions. Why these Cu plus 2 ions are occupied in this position? Cu plus 2 ions plus 2 electrons. So what is happening in this anodic position? Cu is converted to the Cu plus 2 electrons. This liberated 2 electrons are flow from anode to cathode. Okay. So at cathodic position, Cu plus 2 ions are going to occupy on the surface area of electrode. Okay, electrode. Why these electrodes are occupying this surface area of the cathodic electrode? Because of electrons are present in this. So this Cu plus 2 with these 2 electrons, reduction is take place in this cathode. So these are occupying the surface area of the cathode. Okay, so at cathode, Cu plus 2 electrons, we get Cu solid. So Cu plus 2 ions are occupying the surface area of this cathodic electrode. So what happened in this? Reduction is take place. And what happened in this? Oxidation is take place. This one, oxidation. Okay. So by the following this method, the impure metals are converted to the pure form. And extraction of pure metals from the ores like that. This copper sulfate solution as electrolyte, these are electrodes, and this is a anode and this is cathode. So the redox reaction is take place. What is meant by redox reaction? Oxidation and reductions are take place simultaneously in a chemical reaction. By applying of external electrical energy, the chemical reaction take place in this electrolytic cell. Okay, so this copper is liberated in the formation of Cu plus 2 state. Okay, that means oxidation is take place in this, and Cu plus 2 ions are occupied on the surface area of this copper electrode as cathode. So that means Cu plus 2 with 2 electrons we take. What happened in this? Reduction is take place in this. Okay, So reduction is take place. So by the reduction, copper ions are occupied on the surface area of this electrode. Okay, so this is the reaction process. During this reaction, you observe after some time, during this reaction, so this anodic electrode appeared as like this. What happened in this? Why it is appear like this? So impure form of copper is converted to the pure form. That means the impurities, the pure copper ions are going to occupy in this electrode. So that means it is going to appear like this during the chemical reaction after some time. Okay, so this is a electrolytic cell. Oxidation is appeared at anode, reduction is appeared at cathode. Anode is positive, cathode is negative. It is connected to the positive one, and it is also appeared charge is positive. Okay, this also appeared charge only. These are only charge, positive and negative. And this anode, in this position anode, oxidation is take place, and electrons flow from anode to electrode to cathodic electrode. Okay, this is a electrolytic cell.